imagine for a second that you're sitting at a table in a bustling seaside restaurant. The air smells incredible, salt water, charcoal, and that unmistakable scent of garlic butter hitting a hot pan.
Mm-hmm.
The waiter places this massive platter in the center of the table. It's just overflowing with steaming prawns, maybe some crab legs, clams, and a white wine sauce.
The dream.
For 98% of the population, that moment is, pure joy. It's the highlight of the vacation.
Yeah.
But for the other 2%, that plate is biologically equivalent to a loaded weapon.
It is. It's a really high-stakes environment, and the anxiety that people feel is visceral. We aren't just talking about getting a little rash or, having an upset stomach that ruins your evening.
Right.
We're talking about a biological alarm system that can escalate from, I feel a little funny, to life-threatening airway obstruction in a matter of minutes.
And the worst part isn't even the allergy itself, it's the uncertainty. I feel like everyone knows someone who says, I ate shrimp my whole life, loved it, and then one day, bam, I couldn't breathe.
Yes. That adult onset allergy is very common with shellfish.
Or the flip side, which is almost as frustrating, someone who's avoided lobster for 20 years because one skin test back in, 2005 looked a little red, but they don't actually know if they can eat it.
Exactly. They are living in this cage of dietary restriction that might not even be locked.
That diagnostic gap is at the heart of the problem we're getting into today.
That's it, exactly. The tools we've relied on for decades, the ones most people encounter at their doctor's office, are surprisingly blunt instruments. They generate a lot of false alarms, which leads to all that unnecessary fear and avoidance. But even more terrifyingly, they can give false negatives. They can hand people a false sense of security that puts them in real danger at the dinner table.
So that is our mission for this deep dive. We're going to try to solve the shellfish puzzle. We've pulled together a stack of research that bridges the gap between, the basics and the absolute cutting edge.
Right.
We have a comprehensive review from 2016 that lays out all the biological groundwork of what's happening inside the body. But to bring us right up to the present, and today is Sunday, February 1st, 2026, we are analyzing a pivotal study published just last year.
June 2025.
In June 2025, out of Vietnam.
And this study is a fantastic piece of work because it directly attacks that diagnostic gap you mentioned. It looks at what they call an integrated diagnostic approach, and it specifically focuses on a technology called the basophil activation test, or B8.
The BAT, which sounds like something a superhero would use, but I gather it's a bit more microscopic.
Just a bit. It's a way of looking at how your immune cells actually behave in real time, rather than just looking for static markers of past exposure.
So what, like a mugshot versus a live surveillance feed?
That's a perfect analogy. That's exactly it. You're moving from a static picture to watching the event unfold in a test tube.
I love that image. Okay, let's unpack this. Because before we can even get to the high-tech blood tests and the microscopic surveillance, we need to understand what we're actually talking about, what we're eating. I think I use the word seafood to mean, anything from the ocean that isn't seaweed. But scientifically, that's a dangerous oversimplification.
Oh, absolutely. Seafood is a culinary term, not a biological one. If we look at the taxonomy, the family tree, we have two massive distinct kingdoms here.
Okay.
You have the fish. These are vertebrates. They have backbones. They have gills. And then you have the shellfish. These are all invertebrates. Biologically, a salmon is more closely related to you and me than it is to a shrimp.
That is always wild to think about. We are closer to the tuna than the tuna is to the crab.
Exactly. And even within that big, messy umbrella of shellfish, we have to make a hard split. You have the crustaceans and the mollusks. These are the two families that cause all the trouble, but they're quite different from each other.
Okay, so let's break that down. Who belongs to which family? Let's start with the crustaceans first.
Okay, so crustaceans are a type of arthropod. Think of them as the armored tanks of the ocean. They have segmented bodies, jointed limbs, and hard exoskeletons.
The classic sea creature look.
Right. This group includes your heavy hitters: shrimp, prawns, crab, lobster, crawfish. But it also includes some surprises like barnacles and krill.
Barnacles. I don't think I've ever seen barnacle scampi on a menu. Who is eating barnacles?
Well, depending on where you are in Europe, specifically Spain or Portugal, you might. They're called percebes, or goose barnacles. They're actually a high-end delicacy.
Huh. I had no idea.
But yes, for the purpose of allergy, they sit firmly in the crustacean camp. If you are allergic to shrimp, you absolutely cannot eat percebes.
Okay, noted. Avoid the expensive Spanish barnacles. So that's the crustaceans. What about the mollusks?
This is a much more diverse group physically. The 2016 review breaks them down really well. You have the gastropods, that's your snails, whelks, abalone, limpets.
So if you're eating escargot in a French bistro, you're eating a gastropod.
Correct. Then you have the bivalves, two shells hinged together. That's your clams, oysters, mussels, scallops.
Okay.
And finally, the cephalopods, which literally means head-footed animals. This is your squid, your octopus, cuttlefish, calamari.
So here is the million-dollar question, the one that forums are full of. If I'm allergic to shrimp, which is a crustacean, am I automatically allergic to clams, a mollusk?
Not automatically, no. They are biologically distinct families. However, there is this really important concept called cross-reactivity, which we're going to get into in a lot more detail.
Okay.
The clinical cross-reactivity is around 14%. So what that means is if you take 100 people who are definitely allergic to shrimp, about 14 of them will also have a clinical reaction to mollusks.
So it's not a guarantee, but the risk isn't zero.
The risk isn't zero. You have to be careful. You can't just assume you're safe.
The prevalence data from that 2016 review is interesting here. It said global prevalence of shellfish allergy is roughly 0.5% to 2.5% of the population. That seems manageable.
It sounds low, but that number isn't evenly distributed across the globe. It's significantly higher in Asian countries, for example.
And why is that?
It's likely due to dietary habits. In allergy science, exposure often drives sensitization. So if you grow up in a culture where shellfish is a primary protein source, consumed almost daily, you just see higher rates of allergy.
That makes sense.
And unlike, say, milk or egg allergies, which kids often outgrow by the time they hit school age, a shellfish allergy is usually a lifelong companion. It's like a bad tattoo. Once you have it, it sticks around.
And the symptoms, they aren't fun. It's not just a bit of hives.
No, they can be, but they can be much worse. They range from what we call oral allergy syndrome, which is that tingling, itching sensation in your lips and mouth right after eating, all the way up to systemic anaphylaxis.
The worst case scenario.
The absolute worst case scenario. We're talking airway obstruction, a massive drop in blood pressure, which is called hypotension, and then going into shock. It is life-threatening.
I noticed in the notes something called late reactions. That scared me. Because usually I think of allergies as immediate. You eat the peanut, you swell up right there at the table.
Typically, yes. The onset is usually within 2 hours. But with some specific creatures, the review highlights snow crab, cuttlefish, and abalone, the reaction can be delayed up to 8 hours.
8 hours. So you could eat dinner at 7 p.m., go to bed at 11, and wake up at 3 a.m. in a full-blown crisis.
Precisely. And you can see how that makes diagnosing the cause very difficult. The patient might not connect the reaction to the meal they had hours and hours ago. They might blame it on something else entirely.
Yeah, of course.
And there's one more unique presentation we should mention, exercise-induced anaphylaxis.
This one sounds like a glitch in the matrix.
It essentially is. It's a cofactor-dependent allergy. You eat the shellfish and nothing happens. You go for a run and nothing happens. But if you eat the shellfish A&D, go for a run within a certain time frame, usually 2 to 4 hours.
Then you go into anaphylaxis.
Right. The exercise acts as a trigger or a cofactor.
So what's happening there? Why does the run set it off?
The physical exertion changes your physiological parameters. It increases the permeability of your gut. It changes blood flow. And that allows the allergen to breach the system in a way it didn't when you were just resting.
That's terrifying.
It is. It's rare. But for the person experiencing it, it's terrifyingly unpredictable until they figure out that pattern.
Okay, so we have the layout of the animals, the different families, and the symptoms. But let's zoom in. Let's get to the molecular level. What is the villain here? Because the shrimp is just protein, water, and shell. What part of it is actually trying to kill me?
Meet tropomyosin.
Tropomyosin. It sounds like a planet from a sci-fi novel.
It might as well be. It is the major allergen, the villain, as you put it. Tropomyosin is a muscle protein. It's involved in muscle contraction. Every animal has it, humans included.
So why is the shrimp one a problem?
The structure of invertebrate tropomyosin in shrimp, in crabs, and insects is very different from our human version. So when our immune system sees it, it tags it as a dangerous foreign invader and builds an army to attack it.
And this protein is tough, right?
Right.
I read that cooking doesn't destroy it.
That is a key point. Tropomyosin is heat stable. You can boil that shrimp, you can fry it, steam it, put it in a pressure cooker. The tropomyosin remains intact and allergenic.
Wow.
It is also resistant to digestion. It survives the acid in your stomach and enters your gut, which is why it can trigger such a potent systemic reaction. You simply cannot cook the allergy out of a shrimp.
And this leads to the concept of the pan-allergen. This was a big aha moment for me reading the sources.
It is the explanation for why shellfish allergy is so confusing and so widespread within the group. Pan means across or all. Tropomyosin is what we call highly conserved across evolution.
Meaning it hasn't changed much over millions of years.
Exactly. The amino acid sequence, the blueprint of the protein, is over 80 to 90% identical among different crustaceans.
So the tropomyosin in a black tiger shrimp looks almost exactly like the tropomyosin in a lobster to my immune system.
Exactly. So if your immune system creates an antibody, an IgE antibody, to attack shrimp, and then a week later you eat a lobster, that antibody recognizes the lobster tropomyosin and attacks.
And that's cross-reactivity.
That is the textbook definition of cross-reactivity. It explains why about 75% of people who are allergic to one crustacean will react to others in that family. But here is where it gets really interesting. Do you know what else has tropomyosin that looks like shrimp tropomyosin?
I have a feeling I'm not going to like the answer.
Insects and mites, specifically dust mites and cockroaches.
Dust mites? You mean the microscopic things that live in house dust?
The very same. There is a well-documented clinical link where people who are heavily sensitized to dust mites, inhaling them for years and their home develop antibodies to the mite tropomyosin. Because the mite tropomyosin is so similar to shrimp tropomyosin, these people can have their very first allergic reaction to shrimp without ever having eaten it before in their life.
That is wild. So my dusty apartment could theoretically make me allergic to seafood?
In a sense, yes. It's an inhalant allergy crossing over into a food allergy. It's sometimes called the mite crustacean mollusk syndrome. The sensitization happens through the lungs, but the reaction happens through the gut.
That is horrifying, but also just fascinating from a biological standpoint. Is tropomyosin the only culprit? Or are there, henchmen?
There are henchmen. As our diagnostic science has improved, we've identified a number of secondary allergens. There is, for example, arginine kinase, or AK.
What does that one do?
It's an enzyme for energy metabolism. And interestingly, this is another one that is also found in insects like the Indian meal moth and even silkworm larvae.
The insect connection is just so strong.
It's very, very strong. Then there is another one called sarcoplasmic calcium binding protein, or SCP. This one is particularly interesting because it acts as a calcium buffer in the muscle, but the clinical data suggests it's more significant in pediatric allergies.
So a child might react to a different part of the shrimp than an adult would?
Potentially, yes. A child's immune system might recognize this SCP protein more frequently or more intensely than an adult's immune system does.
And any others.
The last major one is myosin light chain, or MLC. It's another muscle protein. But tropomyosin is the king. It's the primary target. If you are screening for a shellfish allergy, you are primarily hunting for an immune response to tropomyosin.
Okay, so we know the proteins, we know the concept of cross-reactivity. Now let's talk about the problem that the 2025 study was trying to solve, the diagnostic dilemma. Because right now, if I go to a doctor and say, I think I'm allergic to shrimp, what happens?
Usually the first thing you'll get is a skin prick test, or SPT. They put a little drop of commercial allergen extract on your forearm, they make a tiny scratch in the skin to let a tiny bit in, and they wait 15 minutes.
And they look for a bump.
They wait to see if a red, itchy bump like a mosquito bite forms.
It's the standard.
Yeah.
I've had it done. You look like a pincushion for 20 minutes.
It is the standard because it's quick, it's cheap, and it's visual. You can see the result right there. But it has flaws. The biggest one is the high rate of false positives.
Meaning, it says you're allergic when you're not.
Exactly. You might get a 30-millimeter wheal, which looks angry and very convincing, but that does not guarantee you will have a reaction if you eat the food. It shows sensitization, not necessarily clinical allergy.
Sensitization versus allergy. We need to really hammer that distinction home for everyone listening.
Absolutely. It's the most important concept in all of allergy diagnosis. Sensitization means your body has produced IgE antibodies against a substance. The antibodies are present in your system.
So the mugshot exists.
Yeah.
The police have the photo.
Right. Allergy means that when you encounter the substance, those antibodies actually trigger the immune cascade, the histamine release, the whole explosion. You can have the antibodies without the explosion. You could be sensitized, but still be tolerant.
So I could test positive on a skin test, avoid shrimp for 20 years, but actually be able to eat it perfectly fine.
Yes. And that happens all the time. It leads to so much unnecessary dietary restriction. And the blood test, the specific IgE test, has the same problem.
How does that one work?
It's a blood draw that measures the quantity of those IgE antibodies in your bloodstream. But again, it's just counting the bullets. It doesn't tell you if they're attached to a loaded gun or if they have a functional trigger. It measures quantity, but not the stickiness or the functional ability to cause a reaction.
And this brings us to the commercial extract problem, which the 2025 study highlighted so brilliantly.
The juice problem.
The juice problem.
Right. When a doctor does a skin test, they use a commercial vial of shrimp extract. But what species of shrimp is in that vial?
I would assume just generic shrimp.
Usually it's whatever species is common or cheap to harvest where the extract manufacturer is located. So a kit from Europe might use a North Sea shrimp, Krangon.
Okay.
But the patient in Vietnam, or for that matter, the patient here in North America who loves Thai food, is eating black tiger shrimp, Penaeus monodon, or giant freshwater prawns, Macrobrachium rosenbergi.
And the proteins in those different shrimp are different enough to matter for the test.
They are. The allergen profile can vary. So the study pointed out that these commercial kits often lack the specific proteins from the local seafood that people are actually eating, and so you get a false negative.
Which is way more dangerous.
So much more dangerous. The test says you're safe because it checked for the wrong shrimp, but then you go out for dinner, eat a tiger shrimp, and have a severe reaction. It's a fundamental failure of the diagnostic tool.
So we have these tests that can lie to us. This leaves us with what they call the gold standard, which is the oral food challenge, or OFC,
right?
Which is just eating it right, in a very controlled way.
Under strict medical supervision, yes. You sit in a clinic and they feed you tiny increasing doses of the actual allergen every 15 to 30 minutes over several hours.
And they wait to see what happens.
They wait and watch. It's accurate because it is real life. You are actually eating the food, but it is time-consuming, it's stressful for the patient and the family, it's expensive, and it carries the real risk of inducing severe anaphylaxis right there in the clinic.
Yeah, you're literally poking the bear.
You are. And for that reason, patients often refuse it. Doctors are often hesitant to perform it unless it's absolutely necessary.
So we have a test that can give false positives and false negatives, the skin prick, and a test that's accurate but dangerous and stressful, the oral challenge.
That's the dilemma.
Enter the 2025 study. The solution.
The solution. The basophil activation test, or BAT.
Let's really dive into this study. It came out of Ho Chi Minh City in Vietnam.
Yes, a team at the University of Medicine and Pharmacy there. They recruited 43 patients who had clear histories of allergic reactions to shrimp and prawn. Now, 43 might sound like a small number.
I'm going to say, yeah.
But in this type of detailed immunological study where you are analyzing live cells from fresh blood samples for every single patient, it's actually a very solid cohort. It's labor-intensive work.
And they did something different with the juice, right? They didn't use the generic European stuff.
This was the most innovative part of their setup. Instead of relying on commercial extracts from Europe or the US, they made their own in-house crude extracts.
What does that mean?
They went to the local market, they bought the actual black tiger shrimp and the giant freshwater prawns that people in Ho Chi Minh City were actually eating, and they processed them into their own testing fluid.
Ensuring the test matched the local diet. That's so smart.
It's crucial. It eliminates that variable of testing against the wrong allergen. Then they compared 3 things for every patient: the skin prick test using commercial extracts, the standard specific IgE blood test, and the basophil activation test using their own in-house extracts.
Okay, so how does the BAT work? You said it's a functional test. It sounds more active than just counting antibodies.
It is a functional assay. Let's go back to our analogy. The skin test puts the allergen on you. The IgE test counts the bullets, the antibodies, in your blood.
Right.
The BAT takes the soldiers, the basophils out of your blood, puts them in a test tube with the enemy, the shrimp extract, and it watches to see if they actually pull the trigger.
I love that analogy. It's so clear. Because basophils are the cells that actually cause the reaction in the body, right? They're the ones releasing histamine.
Correct. Basophils and mast cells are the ones that release histamine and other chemicals called leukotrienes. Those are the things that make you swell up and itch and have trouble breathing. So the BT measures their activation.
And how do you see that? How do you see a cell activating?
When a basophil recognizes an allergen that it's sensitized to and decides to attack, it changes, it degranulates. And as part of that process, it pushes a specific protein called CD63 from inside the cell to the outside surface of the cell.
So CD63 is like a flag being raised. It's a signal that says, I am attacking.
That is exactly what it is. And the researchers use a machine called a flow cytometer, which is incredible technology. It can scan thousands of cells per second with lasers, and it counts how many of those cells have raised the FIDI63 flag.
So what were the results? Was counting the flags better than the skin poke?
It was significantly better. It wasn't even close. We use a statistical measure called AUC, which stands for area under the curve, to determine the accuracy of a diagnostic test. 1.0 is perfect. 0.5 is no better than a coin toss.
Okay. Got it.
In their study, the skin prick test for shrimp using the commercial extract had an AUC of 0.53.
That is literally a coin toss.
In this specific study population, yes, it was very, very poor at distinguishing a truly allergic person from a non-allergic one. The specific IgE test wasn't much better. It came in at 0.57.
Still pretty terrible.
Still in the poor category. And the back.
What was the bad?
The Bay AT had an AUC of 0.88 for shrimp.
Wow. That's a massive improvement.
It's a whole different ballgame. It's night and day. It had high sensitivity, which means it was good at catching the allergy at 77%, and very high specificity, meaning it was good at ruling it out, at 89%.
And what about for the prawns?
For prawns, the AUC was a little lower, 0.74, still in the good category and still far, far superior to the traditional tests.
Why do you think there was a difference between the shrimp and the prawn accuracy?
It seems to come down to the intensity of the reaction at the cellular level. The study found that they needed to set different cutoff points to define a positive test.
What do you mean by that?
For shrimp, if 13.95% or more of the basophils activated raised that CD63 flag, that was the optimal cutoff to indicate a true allergy. For prawn, the bar was higher. They needed to see 23.9% of the cells activate. This suggests that the immune system, or at least the basophils, interact a bit differently with the two species, requiring a stronger signal to confirm the prawn allergy in this testing model.
But the real power move in the study was the combo, right?
Yes. This was a really interesting finding. When they combined the results of the skin prick test with the results of the bait, the diagnostic power for shrimp jumped to an AUC of 0.92.
That's incredibly high.
It is getting very close to the accuracy of the oral food challenge, but without any of the risk. It essentially gives you a way to validate the diagnosis without needing to actually feed the patient the shrimp.
There was one finding in that study that I think is the biggest aha moment for any listener who's ever had a confusing test result. The hidden allergies.
This is fascinating, and it's clinically so important. The study found patients who tested negative on the skin prick test.
Okay, so normally a doctor would say, you're fine, go eat shrimp.
Exactly. That would be the standard advice. But these patients had clear, convincing histories of allergic reactions. When the researchers ran the BT on their blood, the BT came back positive.
And were they actually allergic? Did they confirm it with the oral food challenge?
Yes. The study used a combination of OFC and convincing history as the gold standard. And in 19 cases where the skin test was negative, the B-key correctly identified 11 out of 12 actual allergies.
So it caught the ones the standard test missed. That's potentially life-saving technology.
It really is. It shows that for some people, the beta-phils circulating in their blood are more sensitive or more representative of their systemic risk than the mast cells in their skin are. It's looking deeper into the immune coding.
And what about cross-reactivity? Did the beet help sort out that shrimp versus prawn confusion for people?
It did. They had a subgroup of patients who were known to be allergic to prawns. When they tested those patients with the BP for shrimp, it was 100% accurate in predicting if they were also allergic to shrimp.
100%.
In that subgroup, yes. It takes the guesswork out of cross-reactivity. It gives you a clear answer. Yes, your prawn allergy extends to shrimp, or no, it doesn't. You're only allergic to prawns. That's a huge quality of life improvement.
So if this test is so good, we're talking 0.88 AUC versus a coin toss, why isn't this the standard of care? Why can't I walk into a clinic today and ask for a bat?
It comes down to practicality. The bat has a major limitation. It requires live cells.
The soldiers have to be alive to raise the flag.
Exactly. With the standard specific IgE test, you can draw the blood, separate the serum, freeze it, ship it to a central lab across the country, and test it next week.
Right.
With the bat, the blood needs to be processed very quickly, usually within 24 hours. The cells degrade. If they die, they can't activate, and the test is useless.
So you need the specialized lab to be close to the patient.
Close, and you need it to be equipped. Flow cytometry is an expensive piece of equipment. It requires highly specialized technicians to run and interpret the results. It's much more labor-intensive than an automated IgE test.
So it's a resource issue.
It's a resource issue. So for now, the BIT is likely to remain a step 2 test. It's used in specialist academic centers for complex cases where the skin test and the patient's history don't match up.
It's the tiebreaker.
It is the perfect tiebreaker, and this study from Vietnam proves that it's a very, very effective tiebreaker.
I want to shift gears a bit now. We've been talking almost exclusively about eating shellfish, but one of the most surprising parts of the research stack, for me, was about breathing shellfish.
Occupational allergy. Yes, this is a massive issue in the seafood industry that the general public rarely hears about.
The source material, the 2016 review, mentioned a condition called snow crab asthma.
It sounds like a made-up condition, but it is very real and very debilitating. Imagine a processing plant where thousands of crabs are being boiled and crushed every day.
Okay.
The steam from the boiling vats carries the proteins. Remember, tropomyosin is heat stable into the air. The crushing and processing creates an aerosol mist of crab particles.
So the workers are inhaling concentrated allergen for their entire 8-hour shift.
Exactly. And the prevalence of occupational asthma in these workers is staggering. The review states it ranges from 7% to as high as 36%.
A third of the workers could develop asthma from their job.
In some plants, yes. It's not just an annoyance, it's a career-ending health hazard. It really demonstrates how potent these proteins are. You don't even need to digest them. Just getting them onto your bronchial membranes is enough to sensitize you and trigger a reaction.
Now, speaking of things that people believe about shellfish allergy, we have to address the elephant in the room. Or rather, the element in the room.
Yes, the iodine myth.
I can't have the CT scan contrast die because I'm allergic to shellfish. Every time I'm in a hospital, I hear someone say this.
If I had a nickel for every time a radiologist has had to have this conversation, let's be crystal clear for everyone listening. The allergen in shellfish is tropomyosin. It is a protein.
And iodine is.
Iodine is an element. Number 53 on the periodic table. It is a basic chemical building block. Your thyroid gland is full of iodine. If you were truly allergic to the element iodine, you wouldn't be alive.
So where in the world did this myth come from?
It's a simple case of false association. Shellfish live in the ocean. They absorb iodine from the seawater, so they are rich in iodine.
Okay.
Radiocontrast dye used for CT scans is also rich in iodine. That's what makes it show up on the scan. So people made a faulty connection. I react to shellfish. Shellfish has iodine, therefore I must react to iodine.
But the science is definitive.
Absolutely definitive. There is no cross-reactivity between a shellfish protein allergy and a reaction to iodine-based contrast dye.
So just to be perfectly clear, if you have a shellfish allergy, you are not at any higher risk for reaction to contrast dye than someone with, say, a pollen allergy or an egg allergy.
That is correct. You are an atopic person, someone who is generally prone to allergies, so you might have a slightly higher baseline risk of reacting to anything new, but it has absolutely nothing to do with the fact that your allergy is to shellfish. The iodine connection is a myth.
Good to bust that one so clearly. What about glucosamine? My grandmother takes it for her knees. It always says, warning, contains shellfish on the bottle.
Right. Glucosamine is often extracted from chitin, which is the polymer that makes up the hard shells of shrimp and crab. But remember where the villain is. Tropomyosin is a muscle protein. It's in the meat.
So the shells shouldn't have the protein in it?
Theoretically, no. Or at least very, very little. And the chemical processing to extract and purify glucosamine is quite harsh. Most clinical studies have shown that the vast majority of people with a shrimp allergy can take shrimp-derived glucosamine without any reaction.
Because the villain protein just isn't there, or it's been destroyed.
Exactly. Though, if you are extremely anxious about it or have had a very severe reaction in the past, there are vegetarian glucosamine options available now that are made from fungus or fermented corn, so you can avoid the issue entirely.
Okay, that's good to know. So we've covered the problem, the diagnosis, and the myths. What about the future? Is the only solution for the rest of your life to strictly avoid shrimp?
Right now, today in 2026, yes. The management is strict avoidance and carrying an epinephrine auto-injector, like an EpiPen, for accidental exposures. And that includes reading labels very carefully for hidden sources like fish stock, surimi, or generic seafood flavoring.
But is there anything on the horizon? Immunotherapy.
There is. It's similar to the concept being used for peanut allergy, where you try to desensitize the immune system. But because shellfish reactions can be so severe, researchers are being very cautious. They're looking at something called a mutant tropomyosin.
Mutant tropomyosin. Sounds like a great band name.
It does. Scientists are using genetic engineering to create modified versions of the tropomyosin protein. They design it to be just different enough from the real thing that it doesn't trigger the big allergic explosion when it binds to the IgE antibodies.
But it's similar enough.
It's similar enough that it can still teach the immune system to tolerate the real protein over time. It's like a training dummy for your immune system that can't actually fight back.
So it's a safer way to desensitize.
That's the goal. It's showing a lot of promise in mice models. The research shows it can inhibit that IgE reactivity. It's not in human clinical trials yet, but it offers real hope that we might one day be able to turn off this allergy instead of just avoiding it.
That would be absolutely incredible, truly life-changing.
It would change millions of lives and remove a huge amount of fear and anxiety around food.
Before we wrap up, I want to leave our listeners with a final provocative thought that connects back to something you said much earlier. The insect connection.
The cross-reactivity between crustaceans and insects, yeah.
We hear a lot, and I mean a lot, about sustainable protein. Cricket flour, mealworm burgers, grasshopper protein bars. It's being pitched as the future of food, a solution to climate change.
And from an environmental standpoint, it is. It's incredibly efficient, sustainable, and protein-dense.
But if tropomyosin is the shared villain between shrimp and insects, what does that mean for the millions of people with a shellfish allergy?
It means we have a potentially huge public health problem on our hands. If you are allergic to shrimp, there is a very, very high probability that you will also have an allergic reaction to cricket flour.
So as insect protein becomes more mainstream, as it starts getting used as a hidden ingredient in processed foods, we might see a massive spike in unexpected allergic reactions.
We might see shellfish allergy needing to be rebranded as invertebrate allergy. It's something the food industry and regulators need to be extremely careful about when it comes to labeling and transparency. Can't just call it sustainable protein on the ingredient list.
Wow. From the depths of the ocean to the cricket farm, tropomyosin is the protein that connects them all. A simple muscle protein causing all this trouble.
It's an ancient protein, and for whatever reason, our modern immune system holds a serious grudge against it.
Well, this has been a fascinating deep dive. We've gone from the dinner plate to the basophil cell, from a skin prick to a flow cytometer, and hopefully given you a much better understanding of what's happening inside your body.
It's a really complex puzzle, but with tools like the bidet and a better molecular understanding, we are finally getting the pieces to fit together. We're moving from guesswork to precision.
Stay curious, stay well informed, and as always, read the labels. Thanks for listening.
Thank you.